Have you ever stumbled on a pattern with numbers that just seems impossible? Like a little piece of everyday magic? Well, today we're going to pull back the curtain on this fantastic mathematical trick that seriously looks like magic, but I promise you, it is pure, beautiful logic. Let's dive in. So imagine this. It all starts with a simple observation. You take a few numbers, you do a couple of simple calculations, and somehow, no matter which numbers you start with, you always land on the exact same result. In this case, that number is 2. It feels like it shouldn't work, but as we're going to see, the answer is just so cool. Okay, so let's treat this like a proper magic trick. I'm going to show you exactly how it works, and hey, if you've got a piece of paper or a calculator handy, you should totally try this along with me. You can pick any numbers you want, just as long as you follow the rules.
Here we go. Step 1. We need 3 consecutive square numbers, so numbers that are squares and are right next to each other. For our first go, let's just use the first 3, 1, 4, and 9. That's 1 squared, 2 squared, and 3 squared. Simple enough. Now step 2, add the smallest and the largest ones together. So 1 plus 9 gets us 10. And for the last step, we subtract twice the middle square. The middle one is 4, so twice that is 8. So 10 minus 8 gives us
2. Okay, interesting. But, is that just a one-off, a fluke? Let's find out. Right? I mean, maybe that was just a coincidence that only works with those tiny little numbers at the beginning. To be sure, we got to test it again. Let's try a different set. 25, 36, and 49. Those are the squares of 5, 6, and 7. All right, same rules apply. Let's add the smallest and the largest. 25 plus 49. That's 74. Okay. Now we subtract twice the middle number. The middle is 36, and twice that is 72. So we've got 74 minus 72. And what's the result? It's 2. Again? Okay, so this is definitely not a coincidence. There is something deeper going on here. Seriously, try it with any 3 consecutive squares you can think of. 9, 16, and 25. Or 100, 121, 144. I guarantee you the result will always be 2. And this brings us to the big question. How? How on earth can this simple little process always spit out the exact same number no matter where we start? Well, the answer isn't magic. It's the elegant, awesome power of algebra.
The secret here, the key that unlocks the whole mystery, is something in algebra called an algebraic identity. This is the secret ingredient.
So what even is an algebraic identity? Well, think of it like a fundamental law of the universe for numbers. It's an equation that isn't just true for 1 or 2 specific numbers, but for any values you can possibly throw at it, it's always true. And to really get this, let's look at the difference. You take a normal equation, right, like x squared minus 1 equals 24, that's only true for very specific values. In this case, if x is 5 or negative 5. That's it. But an identity? That's a whole different beast. It's always true. No matter what numbers you choose for x and y, that statement will hold up. That's the crucial difference. Okay, I know. Algebraic identities sound super abstract and maybe a little boring. So instead of just talking about it, let's actually see one in action. I promise it'll make so much more sense. Okay, check this out. Imagine a big square where each side has a length of a plus b. So its total area is a plus b squared. But look at what it's made of. It's built from 4 smaller pieces. You've got that big blue square with an area of a squared, the little yellow one with an area of b squared, and then those 2 green rectangles, each with an area of a times b. So you see, when you add up the areas of those 4 pieces, the a squared, the b squared, and the 2ab rectangles, you get the area of the whole big square. This gives us our first key identity. A plus b squared equals a squared plus 2ab plus b squared. It's not just some random rule somebody made up. You can literally see that it's true.
All right, so this is pretty cool, but you're probably wondering, when am I ever going to use this? Well, more often than you'd think. These identities are actually fantastic shortcuts for doing math in your head. They let us turn tricky calculations into much simpler ones.
So let's say you need to figure out 43 squared in your head. Kind of tough, right? But watch this. What if we just think of 43 as 40 plus 3? Now we can use our identity. It becomes 40 squared, that's easy, 1600, plus 2 times 40 times 3, which is 240, plus 3 squared, which is 9. Add them all up. 1600 plus 240 plus 9, boom, 1849. So much easier. Okay, you with me? We now have our secret weapon. We understand identities.
It is time to go back to that original magic trick and blow this case wide open. So, instead of picking specific numbers like 5, 6, and 7, we're going to go full-on algebra mode. We're going to use a letter to represent any 3 numbers in a row. Let's just call the middle number n. If that's the case, then the number before it has to be n-1, and the number right after it must be n+1. Makes sense, right? This works for any set of 3 in a row.
Now let's just follow the exact same steps from our trick, but with these new algebra terms. First, we square all of them. So we get n-1 squared, n squared, and n+1 squared. Now what was the next step? We add the smallest and the largest squares together. In algebra speak, that's n-1 squared plus n+1 squared.
And now, here comes the magic. We can use what we know about identities to expand this expression. n-1 squared becomes n squared minus 2n plus 1. And n+1 squared becomes n squared plus 2n plus 1. Now, when we add these together, look what happens. The minus 2n and the plus 2n, they just cancel each other out. They completely vanish. We're left with 2n squareds and 2 1s, which simplifies to 2n squared plus 2. Okay, we are so close. The final step of the trick was to subtract twice the middle square. Well, our middle number was n, so its square is n squared. Twice that is 2n squared. So we take our result from before, the 2n squared plus 2, and we subtract 2n squared from it. And what are we left with? The 2n squared terms cancel out, leaving us with just 2. And that's the secret. It doesn't matter what n is. It could be 2, it could be 6, it could be 100, it could be 1,000,000. The n will always disappear from the equation, and you will always be left with the number 2. The magic is revealed.
And this really sums up the whole journey perfectly. We started with a pattern that seemed totally surprising, almost magical. But by using the consistent, logical rules of algebra, we uncovered the beautiful reason hidden just beneath the surface.
This really makes you wonder, doesn't it? The world is just full of these hidden patterns, from the way a plant grows to the spiral of a galaxy. We started with a simple number trick that felt like magic, but it just turned out to be logic. So the next time you see something that seems impossible, maybe take a closer look. It might just be a bit of math in disguise, waiting for you to discover it.